Naseeb Arham. I am coming from Calicut, Kerala. I have done my masters in chemistry from IIT Ropar, Punjab. I have 2-year experience in teaching. So today I am going to teach you the electrochemistry chapter. So electrochemistry is one of the most important and interesting chapter in the physical chemistry part. So today I am going to teach you these things. That is, first I will give a short introduction to the electrochemistry. Second, I am going to explain about the electrochemical cells. In that, I will explain particularly about the galvanic cell. Then I am going to explain the electrode potential. Then I am going to explain the standard electrode potential represented as STD. Then I am going to explain the cell potential. And last, I am going to explain the inert cell calculation. Fine. So these are things which I am going to explain in this short lecture. So what is electrochemistry? Electrochemistry deals with the it is a branch of chemistry which deals with the energy conversion between the electrical energy and chemical energy. So in electrochemistry we will get the idea of the electrical energy, relationship between the electrical energy and chemical energy, and their conversion, that is from chemical energy into electrical energy, and electrical energy into chemical energy. So in electrochemistry we will get the idea of the conversion of chemical energy into electrical energy and electrical energy into chemical energy by the electrochemical process. So one of the example in the environment is the rusting process, right? The rusting of iron is one of the beautiful example of electrochemical process, right? Electrochemical process. Okay, so we use one device which is called the electrochemical cell. We use the electrochemical cells to study the conversion of the transformation of the energy from chemical energy into electrical energy and electrical energy to chemical energy. So electrochemical cells are the device which are used to study the conversion of this energy, right? There are two types of electrochemical cell. One is the galvanic cell and one is the electrolytic cell, right? In galvanic cell we will learn about the conversion of chemical energy into electrical energy, that are represented as CE, that is chemical energy, and EE, that electrical energy. In electrolytic cell we will study the electrical energy is converting into chemical energy. Fine. So today I am going to explain about the galvanic cell. I am going to explain the galvanic cell. Galvanic cell. So galvanic cell used to study the conversion of chemical energy into electrical energy. Okay, so I have taken the zinc and copper system to explain the galvanic cell, that is the conversion of chemical energy into electrical energy. So for that, people have taken two beakers. In one beaker they have taken zinc sulfate solution, right? In one of the beaker they have taken the copper sulfate solution. So we know that zinc sulfate will dissociate into zinc +2 and SO4 2-, and we know that copper sulfate will dissociate into copper +2 and SO4 2 minus. Fine. So this is solid, this is solid, this is in the aqueous, right? Both are in aqueous condition because they are dissolving in water. Okay, so they have taken zinc rod, solid zinc rod, and dipped in the zinc sulfate solution, and they taken copper rod, solid copper rod, and they dipped in the copper sulfate solution. Then they connected these two rods with a conducting wire, and they connected one bulb. Okay, so they have taken conducting wire and connected the two rod. So they found that the bulb is getting glowing, right, which are represented like this. So the bulb is getting glowing. So they found that the chemical energy is generated. Okay, so what is happening here? After connecting to this rod, conducting wire is connected to the rod, the bulb is getting glowing. So what is happening here? So we know that in zinc rod, this is the zinc rod, this is the copper rod. So in zinc rod we have zinc, right? Zinc, solid zinc we have, it will dissociate into zinc plus 2 electron, right? These 2 electron will travel from this zinc rod to copper rod, right? In copper sulfate solution we have copper plus 2 ions, right? These copper plus 2 ions will take up these 2 electron from this. After the 2 electron reached the copper rod, right? They have taken the 2 electron and become copper, that is solid, right? This is in aqueous, this is in aqueous. So after zinc losing 2 electron, and this zinc 2 plus will dissolve in the zinc sulfate solution because they are not either the solid form, right? So they get dissolved in the zinc sulfate solution. But in here we have copper sulfate solution already in the solution, right? Copper plus 2 is already in the solution, right? So this copper 2 plus will migrate to the copper rod, and they have taken 2 electron which is loosed by our zinc electrode, right? And they will take the 2 electron and become copper. So this is the process that is happening, so that electrical energy is generated, and we got the electrical energy by glowing the bulb, right? So what is this process, right? So this process is that zinc is losing 2 electron. That is the process called oxidation, right? So represented oxidation, right? So this process is called reduction, right? So reduction, right? So what is happening here? Here copper 2 plus is gaining 2 electron and converting into copper solid, and zinc is losing 2 electron and converting into zinc 2 plus by losing 2 electron. That is called the oxidation. So how to remember that oxidation is losing and reduction is gaining 2 electron? So there is a small mnemonics that you can use, that is oil rig. So oxidation is losing and reduction is gaining. So you can remember this mnemonics to remember that oxidation is losing 2 electron and reduction is gaining 2 electron. Fine. So always remember that wherever the oxidation is taking place, that electrode we consider as anode, right? So here oxidation is taking place. Here zinc is giving 2 electrons, so oxidation is taking place at this zinc rod. So this rod is called as anode, right? So this wherever the reduction is taking place, that electrode is called as cathode, right? So this is the cathode. So always remember, wherever the oxidation is taking place, that electrode is called anode. Wherever the reduction is taking place, that electrode is considered as cathode. So there is another mnemonics you can use, that is an ox red cat. Okay. So you can remember this mnemonics, that anode oxidation, reduction is cathode, right? So you can remember that thing to remember that that always remember that anode is the oxidation taking place at anode and reduction taking place at cathode. Fine. So there is a question is arised, why the copper 2 plus is not losing 2 electron and zinc 2 plus is not gaining electron. We found that zinc 2 plus is giving 2 electron and copper 2 plus is gaining 2 electron, right? So why that opposite thing is not happening? That is because of the potential. Okay, so I'm going to explain the electrode potential. Electrode potential. So there are two types: oxidation potential and reduction potential, right? So we come to know that the copper has more reduction potential. That is, copper has more tendency to gain electron comparing with the zinc, right? So copper has more tendency to gain electron than zinc. Copper has more tendency to gain electron than zinc. So copper will gain electron and zinc will lose electron. Why zinc is losing electron? Because zinc has less tendency to gain electrons. So zinc will lose electron, copper will take 2 electron, right? So now we understand that why copper 2 plus is gaining 2 electron and zinc 2 plus is leaving 2 electron, right? Because copper 2 plus has more reduction potential compared with the zinc, right? So that's why copper is gaining electron and the zinc is losing 2 electron, right? So how this potential is generated? So we know that this electrode has negative charge, right? Why? Because the zinc will lose 2 electron and 2 electron, that electron will be concentration will be more in this single electrode, right? So what is the charge of the electron? That is negative charge, right? So that's why the electrode charge will be negative, and here copper 2 plus will be more towards the electrode. That's why this copper electrode will carry a positive charge. So we know that opposite charges attract, right? So we have zinc 2 plus in the solution. So this zinc 2 plus will migrate to here and will align to the negative charge. Same for here, SO4 2 minus will migrate to the rod and align to the positive charge. So the positive and negative charge, this charge difference between this will generate a potential. That is because of that this process is happening. Why? That is called the electrode potential, right? So what is electrode potential? It is the potential generated by the charge difference between electrode and solution, right? So that is the electrode potential. Fine. Now I am going to explain the standard electrode potential, right? So we know that this is one of the half cell reaction. This is another half cell reaction. This is a full cell reaction. Okay. Now I calculated the half cell potential of this. That is the oxidation potential I calculated. I got any value x. I taken x, right? X volt. Fine. And I calculated the reduction potential. I got y volt. Okay. So I calculated this x and y at some conditions, right? I fixed some conditions. What are the conditions? So I fixed some parameters, such as pressure, temperature and concentration. I fixed the pressure at 1 atmosphere pressure, temperature as 298 Kelvin and concentration as 1 molar. Fine. I fixed the concentration of zinc sulfate solution, copper sulfate solution as 1 molar, and I fixed the temperature by by using some things, and I fixed the temperature by 298 Kelvin, and I measured these two half cell potential and I got x and y. So this is called the standard electrode potential of this half cell. This is the anodic half cell, this is the cathodic half cell. So that is called the standard electrode potential. Right? Now I am to calculate the full cell potential. For that I need to, so I know that there is the I know the value of oxidation half cell and reduction half cell. So I need to calculate the cell potential. So for that, so I just added the two half cell reaction I just added. So two electron will cancel each other, and rest will be zinc plus copper plus 2 gives zinc plus 2 plus copper, right? This is the full cell reaction. Fine. So we know that zinc is converting into zinc 2 plus, that is the oxidation process. Copper 2 plus is converted to copper, that is the reduction process. So I got the oxidation and reduction from the full cell reaction. So in order to calculate the cell potential, the cell potential will denote by E cell, right? I will add the oxidation potential plus I will add the reduction potential. Fine. So I calculated the oxidation potential and reduction potential at standard condition. So I denote like E naught, right? So I know the value of E oxidation is X, and I know the value of reduction is Y volt, right? Y volt. So this will be the full cell potential at standard condition. Fine. So always remember, if we calculate the E oxidation, that will be the negative of E naught reduction. Fine. Example, if zinc gives zinc 2 plus 2 electron, that oxidation potential will be X, then same will be minus X. Then the reverse, that is the reduction of zinc, that is zinc 2 plus 2 electron gives zinc, that will be the negative of oxidation potential. So always remember these two things. This is one of the previous year question. So we need to calculate the E naught cell value. Okay, so at standard condition it is given that tin plus 2 iron plus 3 gives 2 iron plus 2 plus tin plus 2, right? So how we calculate this? So from this full cell reaction we can know that tin is converting into tin plus 2, that is oxidation, right? And iron plus 3 is converting into iron plus 2, that is reduction. Fine. And we know the equation, that is E naught cell equal to E naught oxidation plus E naught reduction. So I need the oxidation potential. So tin is converting to tin plus 2, that is the oxidation process, right? But here they are given the tin plus 2 is converting to tin, that is opposite they give, that is they given the reduction potential, that is minus 0.14. So I reverse the side, that is positive 0.14 volt, right? Then the iron plus 3 converted to iron plus 2, that is reduction potential we need to know. So they are given the same iron plus 2, iron plus 3 is converted to iron plus 2, that is 0.77 volt. So after that we got 0.9291 volt. So in conclusion, I have explained about the introduction of the electrochemical cell. In electrochemical cell I have explained the galvanic cell construction, working principle, and the electrode potential, how electrode potential is generated, standard electrode potential and cell potential, and last E naught cell calculation. So in next lecture I am going to explain why we calculated the E naught cell. What is the benefit of calculating the E naught cell? What else we will get from this E naught cell? That I am going to explain in my next lecture. Thank you.